Hey, Bert, you should say that again for the camera.
Can we give Gavin 3 strikes again? Like in first, remember that?
No, parent teacher conferences are coming up soon.
Then Mr. Burkham stops him.
Okay,
What
make
is
a
that?
slice of pizza.
No, I choose my arrow.
Can we do a table or just have?
So, we got a slice of pizza, and this is a mirror.
Mirror.
Okay?
Mirror?
Oh wait, I forgot.
Concave, convex.
Concave.
I got a focal length at 20. I've got my slice of pizza outside of the focal length. Now, let me give you a hint when you draw images with mirrors. The first one that you always draw goes from the object to the center line of the mirror where that primary optic axis exists. And then whatever distance this is if you're drawing this by hand, I don't care what the scale is. Maybe this is 2 centimeters above when you're drawing it. Whatever that dimension is. Right?
Same on the other.
If that's 2 centimeters, you measure down 2 centimeters and you take that line and you bring it back out like this. Okay?
Yeah.
So that's the first
Yeah,
thing
sure.
that you do.
Yeah.
Whether it's concave, convex, inside the focal length, outside the focal length, does not matter. The very first line that you draw is symmetrical about whatever that object is. So you put it wherever that is. However you set up your scale, if you let it be 1 centimeter, 2 centimeters, doesn't make any difference. This is completely symmetrical triangle.
Really?
No.
No, he just told us all that, and he was lying.
He's gaslighting you.
Now, the other thing that can
Making it
happen,
up.
and this will be important later on, you also want to extend that same line back as a dashed line. Okay? Because what you'll see is that sometimes the image is going to form on the other side of that, and that's why you always want to establish that dashed line. Now, here's the beauty of this. What that tells you is one of two things. Either the image can only exist in one of two places. Either that image is here, or the image is on the other side.
How can it be on the other side?
This, it's an image.
No,
Okay?
the dashed line. It's
The dashed line goes on the back side. So when you have mirrors, it's either on this side or it's on the other side. That's it. Now, if it's on this side, on the side that the object is in, if it's in this triangle off to the left, is it going to be upright or inverted? Inverted. It's going to be inverted. But if it's on the other side, it's going to be upright. Okay? Because you're going to see the top of that pizza on the other side. It's not there, but it's going to appear there. So, when you have mirrors, it's either here or it's on the other side. Then,
Why is the dashed line following the reflected
Yeah,
light
so-
and not the direct light?
because what's going to happen is that if your eyeball is out here, your eyeball is going to pick that up and your eyeball is going to think it's on the other side.
Okay.
Okay? That's why.
Okay.
Okay.
Mr. Burke, one question. How are we going to see behind him here when we're in front of him?
How?
That's
Just
That's a
stop.
good example. Just stop.
That's genuine.
So,
Oh.
in this situation, is my focal length going to be a positive or negative value?
I don't know.
They go apart on the right side.
Oh, no.
Okay.
This light, like this light would hit here, and then it would go through that focal point.
Coming together.
Ah, it's coming together. It's bringing the light together.
Positive.
So the focal length is going to be a
Positive.
beautiful.
Ah.
So my focal length in this case is going to be a positive 20 centimeters. See the pattern?
Yes.
Where we're going with this.
Yes, sir.
So I got 1 over so plus 1 over psi equals 1 over f. Okay? So 1 over my focal length minus 1 over psi, or so, is going to give me 1 over my image. So in this case, I got 1 over 20 minus 1 over 40, and then the inverse of that. And you get 40 centimeters. So what's my magnification? So magnification is going to be a negative 1. Why?
Negative.
It's inverted, and it's the exact same size. So what that tells me is my slice of pizza, in this situation, is going to appear upside down. Okay? But it's going to be the same size. It's going to be upside down. Now, the second one, and I got to get this through this fast. The second one, okay, over here, you have a concave mirror. So on the second one, I have the exact same mirror, and I'm going to move this over a little bit. So I'm like this. So on the second one, I tell you that the object distance is 20, the focal length is 40. So on this one, the focal length is way out here. That's 40 centimeters. But my pizza slice is in here. So what's the first line that you draw?
Our top
Symmetry.
Symmetry. So this is going to come in here like this. Whatever the height of the pizza is, I draw the same thing back here. Okay? And I'm going to take this line, continue that on the back side. Okay? Continue that on the back side.
Yes.
Now, when I draw the second one, okay? The second one is going to come here. It's going to hit, and it's going to try and go through that focal length. But now, if I extend that line back, notice that it intersects way back on the other side. Now, here's an interesting thing that happens. With this one, notice that these lines will never meet because they're divergent from each other. So even though the light converges, these lines will never meet. But those lines over there will. So I'm going to get a pizza way over here that's going to be bigger and
Because it's construction.
upright.
Upright.
Okay, now look at the math.
Wait, it's bigger because it's constructive. Interference.
No, don't throw constructive and destructive into this.
Well, sine is negative.
Okay.
No, that has to do with weight. We're talking about.
All right.
So I got 1 over so is going to equal my focal length, which is now 1 over 40 minus 1 over 20. Okay? So now, somebody take 1 over 40 minus 1 over 20 and take the inverse of that.
Negative 1 over 40.
What do you get?
Negative 40.
Negative 40. Oh! I got a negative 40.
Wait, I thought that was sine. Are we not sorry?
Oh, I'm sorry. That's sine. My bad. My psi is negative 40. So what's my magnification going to be?
Positive.
Positive value.
Big positive.
Big positive. This is your makeup mirror. You're inside the focal length. You're creating a positive image, positive value. So your upright value. Okay? So when you do your magnification, you have a negative of a negative, which makes it
Positive.
and it is
Upright.
upright.
Nice.
Now, real quick, the last one. If you have a concave mirror, so here's your slice of pizza. Come in here. You got this. You got this. Now,
That's what we
concave
convex.
mirrors only produce images on the other side. Okay?
Convex.
So this is going to be a convex mirror. Okay? So if I let the focal length be 20 centimeters and my object distance is 40 centimeters. So I got, look at this. Is my focal length going to be a positive or negative value?
Negative. We're going away from each
Negative.
other.
Why? Because the
Away.
light's going to hit and it's going to
Bounce off.
diverge. Okay? It's going to diverge. So my focal length is going to be a negative number. So somebody right quick. Take 1 over negative 20 minus 1 over 40 and the inverse of that.
Negative 13.3 repeated.
Negative 13.3 centimeters. Now I have a negative image distance. So I have a negative of a negative on my magnification, which makes it positive, which is why this thing is going to be upright.
But it's big.
But small. We've got thin lens. Okay, we've got thin sliced pizza. So this is what I'm showing you. So this is going to go try and go through the focal length on the other side. This is why you don't have convex lenses for makeup mirrors, because you always be upside down. Okay. Okay.
No, don't do that.
Oh, I'm doing it. Oh, I'm doing
I
it.
thought we were in the clear.
Oh, no, God, no.
Okay, but it makes there's 3 minutes up the clock.
I had to run. Well,
Is it a real
if you guys had one in
There's a bag.
Bird.
Oh, there's very much a back.
Basic stop.
Realistically, guys, if you think about it, it's
one
not
too.
that bad.
Hey, Adam.
Adam, shut up. Shut up, Adam.
Adam, do more homework.
Okay. There's different parts to this. Very quickly. Gavin?
That's at least 4 signals.
So, on 1 through 5, these you do on another sheet of paper. You are actually going to measure these out. You are going to set up a scale. Like maybe 2 centimeters equal, like on your drawing, maybe 2 centimeters equal centimeters, something like that.
Actually?
Yes. So you're going to label the object, the image distance, the focal point. You are not using math. You are doing all of this. On another sheet of paper, you are doing these diagrams. Not here. On another sheet of paper. You are going to, based upon your diagrams, determine the image distance, whether it's upright or inverted, magnification. I know there's some variance on the theme, but that's what you've got. Now, then, the next part, you're actually going to see what the values are. Then you're going to use the thin lens equation to actually get the values to see how they compare. When you get to the backside, I tell you, on the line provided, make a sketch labeling the object and the image. These do not have to be to scale. If you want to, that's great. But at least make a sketch. You're going to do math to figure out the answers. Okay? So, 1 through 5, neatly drawn. Another sheet of paper, sharp pencil. Okay?
Si, senor.
All right, go be free. That was a lot.